Hello everyone, in this video we are going to write a program for decimal addition of two 8-bit numbers where the sum is 16-bit. So here this program is an example where we will use DAA instruction. Okay, so suppose the two 8-bit numbers are previously stored at two consecutive memory locations, that is the first number 84, suppose it is stored at location 2051 and the second number 75 is stored at the memory location 2052. Now after decimal addition, what will be the result? So here in the program it is already mentioned that the result is 16-bit or the sum is 16-bit. So after adding 84 and 75, the result is 159. So I can tell that 59 is the least significant digit and 01 is the most significant digit. So we will use one 8-bit memory for storing 59 and another 8-bit memory location will be used to store the most significant digit. So that is what has been written here. So we will store the sum at location 2053H and 2054H. So this is the overall idea of, this is a briefing of the whole program. Now we will start writing down the program. So first what we will do, we will load the memory location in HL register. So here in HL register pair I will store 2051 because at 2051H memory location my first data is saved, that means 84 is saved over here, and at location 2052H I have saved 75. Okay, so first I have loaded the address in HL register pair, then I will initialize one register to 0 where I will store the most significant digit. So here I will initialize a register C with 0. Then what I will do, I will move the content of this memory location to the accumulator. So for that I can use the command MOV. So MOV A comma M. So here what will happen by this instruction? So M means the memory location 2051. So the data stored at 2051 is 84. So this will be copied to the accumulator. So after this instruction my accumulator will contain 84. Now for addition I need to have the access to the second number, that is 75. So what I can do, I will increment the register pair HL. Okay, so now my HL pair will contain 2052. Now what I can do, I can simply write down add M. So here what will happen? The content of the memory location pointed by HL register, that is 2052, will be added to the accumulator's content. So here with accumulator the content of the memory location will be added, that means 84 will be added to 75. So after this instruction the result will be in hexadecimal, because we know that the result of add instruction is in hexadecimal, but what we want the result in decimal, isn't it? So for that we can use the command DAA. So DAA stands for decimal adjust accumulator after addition. In case you don't understand how DAA instruction work, you can follow one of my videos whose link is provided in the description section. So after DAA it will it will adjust the accumulator, the content of the accumulator into decimal number system. Then after DAA I'll be having the result, but in case here I have told that the result is in 16 bit. So I have to check whether a carry is generated or not. So if there is no carry, then I will simply go to one loop. Suppose the label to that loop is loop 1. So if there is no carry, then I can jump to here, where I will store the result in the memory location 2053H. So here, after using DAA, the decimal result or decimal summation result is stored in the accumulator. So by using the command STA, the accumulator's content is stored in the memory location 2053H. Then we will move the register's C content to the accumulator, because I have previously told that C contains the MSD, that means most significant digit of the result. So in case there is no carry, so the content of the register C will be 0, and simply we will move that to A. Then I will store the result or store the most significant bit in the location 2054H. Okay. So in case the most significant digit is 0, so 0 will be stored here. Okay. In case there is a carry, so what will happen? We will simply increment the register C. Okay. So in case there is a carry, so what will happen? Initially we have initialized C with 00H. So in case there is a carry, so what will happen? The value of C will be incremented by 1. Then it will follow the same these 3 steps, and after that we will come to the end of the program by using the instruction halt or HLT. So this is the complete program for addition of for decimal addition of two 8-bit numbers where the sum is 16-bit. So here at 2053 the least significant bit will be stored, that is 59 will be stored here, and at the next memory location, that is 2054H, the most significant bit 01 will be stored here. But if you access both of the content of this location, so your complete result will be there. Will be 01 and 59, that is 159 in decimal number system. So this is how you can write a program to add or to decimally add two numbers where the sum is 16-bit. So there are several ways to write the same program. If you are writing this program in another manner and achieving the same goal, then this is completely fine. So please write down this program in a simulator and check whether it is working or not. And for a programmer, it is always a feel-good factor to see your program running correctly in any kind of simulator. So please write this program in a simulator and check the result. You will feel nice. So thank you for watching my video. In case you have any query, you can put in the comment section. I will definitely address it. Thank you once again.